Okay, so this problem is going to be y prime plus y equals g of x, with y of 0 equals 5, and g of x equals 3 or 2, depending on condition 0 is less than or equal to x, x is or guess 0 is less than or equal to x, x is less than 5, or x is greater than or equal to 5. So for step 1, part 1, we're going to take our equation y prime plus y equals g of x, but our g of x is going to be 3 this time. So we can use Bernoulli's to see p of x is going to be equal to 1, because it's already in the form, the 1 would be right there, and our g of x is going to equal 3. Then we can find the integrating factor, e to the integration of p of x dx, and that equals e to the integration of 1 dx equals e to the x. So step 3, you take your integrating factor times your g of x, and that equals e to the x times 3 dx. You can pull that 3 out. The integration of e to the x is e to the x plus c, and that leaves you with 3e to the x plus c. Step 4, you multiply y times your integrating factor, set that equal to this answer you just got, 3e to the x plus c. Now you solve for y. That gives you y equals 3 plus c over e to the x. Now we're going to plug in our initial condition, y of 0 equals 5. So for every x we'll put a 0, for every y we'll put a 5. So 5, and this pen is horrible. 5 is equal to 3 plus c over e to the 0. And e to the 0 is 1, so we'll just know that there's a 1 there. 5 is equal to 3 plus c. c is equal to 2. So when we plug this 2 back into this equation, we get y is equal to 3 plus 2 over e to the x is our answer for that part of the equation. Now we will have to integrate that from 0 to x per our initial condition here, and we'll have y e to the x dx equals 0 to x, 3e to the x dx. Y e to the x, 0 to x, equals 3 e to the x, 0 to x. Okay, so now we'll go back up here to our original problem. Y prime plus y equals gx, and we're going to set the gx is going to be 2 this time. So, step 1, y prime plus y equals 2. Our p of x is going to continue to be 1, so it's right there, and our g of x will be 2 this time. We don't have to find the integrating factor because we know p of x is 1. We know it's going to be the same as this one, e to the x. So go down to step 3. And we know we multiply our integrating factor by g of x. So it's going to be e to the x times 2 equals dx equals 2e to the x plus c. So step 4, we have y times e to the x equals 2e to the x plus c. And when we solve for y, we get y equals 2 plus c over e to the x. So now we do have to do a little integration from our points x less than or equal to 0, x is greater than or equal to 0, x is less than 5, x is greater than or equal to 5. So because x is greater than or equal to 5, we will start with this one. 0 to 5, we'll take g of x times e of x dx plus 5 and 6, because x is greater than or equal to 5, so we'll just put 6 up there because it is greater than or equal to 5, g of x, ex, dx. So we do have our equations here. This one should be 0 to 5, sorry. Our original one from here, 3e to the x dx, have it here, plus 2e to the x dx from this equation here. And when we solve, we get y e to the x 0 to 2 equals 3e to the x 0 to 5 plus 2e to the x 5 to x. Breaking that down, we'll get y x, let's fix that, y times x e to the x minus y times 0 e to the 0 equals 3 times e to the 5 minus e to the 0. This is still part of the same line, plus 2 e to the x minus e to the 5. E's 2. So now you solve for y and simplify, and you'll get y is equal to e to the negative x times e to the 5 minus 3 plus 2. And that is your solution to this problem.